A very good morning, all the participants and our speaker, sir. I'm very glad to introduce my mentor, my supervisor in this FDP. Professor Fazal A.Talukdar is a great academician and the administrative leader. His unbiased approach to handle any situation guided me to tackle my real problems. He always motivate the students. He is a very energetic person. I am very thankful to sir for taking time for his busy schedule for this our FDP. Sir, we welcome you back. And over to you, sir. Kindly start the session, sir.
Thank you. Yeah, thank you, Dr. Ramkumar. Thank you so much for inviting me in this FDP. And I will share some of the thought which I am having on the topic which is assigned to me. I do not know whether everybody will really appreciate, but what you can do we can always carry forward this discussion and accordingly we will try to find out some common research areas. So without wasting any more time, let me just share my screen. Is my screen visible?
Sir, it is clearly visible.
Okay. So yeah, I will speak a little bit on computer-aided diagnosis of medical images using deep learning. And Dr. Ramkumar has already introduced me, as well as the Madam Principal also introduced me about me and what I really do. I am a professor in the Department of Electronics and Communication Engineering at National Institute of Technology, Silchar, which was formerly called the Regional Engineering College, Silchar. I was a student there for my undergraduate. At that time, it was only an undergraduate institute. So before I actually move into my assigned topic, let me just share with you some facts regarding the place where I work for. So National Institute of Technology, Silchar is one of the 31 National Institutes of Technology in India and was established in 1967 as Regional Engineering College, Silchar. In 2002, it was upgraded to the status of National Institute of Technology and was declared as Institute of National Importance under the National Institutes of Technology Act 2007. NIT Silchar offers undergraduate and graduate programs in engineering, science, humanities with 11 departments. The annual intake of BTech students is approximately around 900. Because we have a supernumerary quota for girls. So at that very every year, this is one of the reasons I cannot exactly tell you what the intake is. The official intake is 825, and we need to accommodate as per the Government of India policy. 20% of the girl students, their number is less than this one. So sometimes what we find is that we need to admit around 75 to 80 girls extra compared to 825. So this is the reason that we say that seem to be approximately around 900. We also offers around 17 postgraduate programs in Master of Technology, as well as 3 master's level program, mathematics, physics, and chemistry. Yeah, we do run a program on management. We have a Kendriya Vidyalaya, which has it up to class 12 in our campus. We also have our own pre-primary school. And NIT Silchar was ranked 46 among engineering colleges in India by the National Institutional Ranking Framework in 2020 with an overall rank of 94. Okay, so just having a look into this abstract information about my institute, you can very easily make out in that we are almost a self-contained institute right from the pre-primary level up to the PhD level. And currently, our chairperson is Sri G.N. Behra. He is the chairman and managing director of Savita Oil Industries Limited, based in Mumbai. Our director is Professor Shivaji Bandyopadhyay, who is a professor from Jadavpur University, and he is also from the computer science and engineering. So just have a aerial view of the campus. Dr. Ramkumar was also a student here. He spent approximately around 6 years in our campus. Unless you are in our campus, you will not really appreciate how beautiful and how green it is. It has around 23 lakes and almost 80% of under greenery. Okay, so these are the various kind of our standing in the academic ecospace. Okay, as I already mentioned, we are NIRF rank both for engineering as well as overall category. We are also in the rank band of 10 to 25 in all that. We are also the second best institute, government institute in the eastern region. Okay, other than that of Guwahati, and we are the 32nd the best engineering colleges all over the country, as announced by the week magazine. India today the place stars that fit in East Zone and 26 among the government engineering colleges, and from the international one, we have been there in the Times Higher Education ranking for 21 as well as for 22. We are also identified by US News, one of the leading academic institutions in the world, and we are found to be at 750th position. Vis-a-vis your science and engineering research is concerned, the Times Higher Education place stars between 600 to 800 rank band. The University of Malaysia, okay, the green ranking put us at in the range of around 275 green campus across the world. And in the Times Higher Education impact ranking, we also have a best rank of 251 to 300 in some of the categories. Okay. Let's come back to the department where I work for. We offer postgraduate PhD program in all specializations. We also offer MTech in 2 specialization, micro electronics and VLSI design, and second one is communication and processing engineering. And we also run a BTech program which is the original program in electronics and communication engineering. And now let me come back to the topic which I will be discussing you for next 1 hour. This is regarding what is called your computer-aided diagnosis of medical images using deep learning. And through this one, what I will do I will share some of the work done by this group in our department, and the work I as well as the work which are carried by my colleagues in the department. And I offer you a standing invitation if you wish to have some kind of collaboration in any kind of research activity, electronics and communication engineering, in the broad domain of electronics and communication engineering. We are open to such proposal, and we can always work out what we should do so that the research ecosystem across higher educational institutions in the country improve. The first one is what is called your medical imaging. What is really medical imaging? Medical imaging is a technique and process of creating visual representations of the interior of a body for clinical analysis and medical intervention, as well as visual representation of the function of some organs or tissues. So even though this medical imaging is something which is generally captured by medical people, but normally what happens is that once a particular kind of imaging is captured, the doctors usually go for a qualitative kind of assessment. And definitely the moment you make a qualitative kind of assessment, there is the possibility of some kind of error. So generally over the last few decades, what we observe is that the general trend is for people to migrate to medical imaging to analyze the same. And with the advent of high power or computer systems available, what is going to happen is that it has the ability to have some kind of a mechanism through which we will be able to pinpoint exactly what is the cause, which is otherwise not possible from a visual inspection. Okay, so what really happens is that the medical imaging seeks to reveal the internal structure hidden by the skin and bones, as well as to diagnose and treat the diseases. Okay, so once that means we capture a medical image. Generally, that means of the internal structures which are hidden by our skin and bone. What we can do just by having a look into the same, we are able to diagnose what is the problem. And once we can diagnose what kind of problem is there, we can identify what kind of disease the person is infected with, and accordingly the medical people can prescribe some kind of medicine, and so therefore the treatment of the disease is possible. Medical imaging also establishes a database of normal anatomy and physiology to make it possible to identify the abnormalities. Okay, so in addition to that, with the diagnosing as well as you're treating a disease, what we can do is that it can really create a database of anatomy and physiology, and this database can be very easily identified or analyzed to see what kind of abnormalities are present. Even though the person may not be suffering from a disease, but he may be suffering from some abnormalities. Okay. Although imaging of removed organs and tissues can be performed for medical reasons, such procedures are usually considered part of pathology instead of medical imaging. This is also something that is very important. And what is very important for every one of us to know that. Okay, so we can do we can do the imaging of removed organs as well as tissues, but generally this is something which is not considered within the domain of medical imaging. Rather, this is something which the pathologists look into and try to find out what could be the causes and what kind of remedial action can be obtained. Okay. The study of the medical imaging is concerned with interaction of all forms of radiation with the tissues. Okay, so how do we get for the medical imaging? Subsequently, we will find that there are capturing mechanism and the various kind of medical imaging technique. Okay, so what we do is that the study of medical imaging is concerned with interaction of all forms of radiation with the tissue, and the moment such kind of your interactions with tissues are observed, we can create an image based on how this radiation behaves with the tissues. The development of appropriate technology to extract clinically useful information, usually in the form of an image from the observed technology. And generally, this kind of medical imaging is usually the non-invasive visualization of the internal organs, tissue, etc. Now a question will automatically come: is endoscopy and imaging the modality? The answer could be yes. The answer could be no. Because in case of the endoscopy, it is not a non-invasive process. It is essentially an invasive process. But by and large, most of the medical imaging we engineer or the people from the science understand, they are usually a non-invasive kind of a thing. And what we can do is that the moment a medical image is captured, it can be captured either as a 2D signal, the function of f of xy, or it can be a 3D signal. Okay, it can be f of xy z. And once we are having 2D images, we can reconstruct and we can process the same. We can sometimes be also able to create your 3D images. One of my students very recently defended his PhD thesis, and what he did is that he also converted. He converted a 2D image into a 3D one. Okay, so the overall objective of medical imaging is to acquire the useful information about physiological processes or organs of the body by using external or internal sources of energy. Having said that, the medical imaging generally what we come across is some kind of database, because quite often the doctors do not share the images which they capture due to privacy or other reasons. But for research and other things across the globe, we are having now lot of that means the medical imaging, that means the databases of that means the appropriate one. Okay, so now this what you find that means from this table of contents, this is what is the medical imaging, that means the, which is just the, that means the beginning. Now the second one is what you find is that the types of that means the medical imaging. So there are various kind of that means the technique. There are various kind of that means the physical processes. Yeah, or that means something that means which will be that means used to that means capture medical images. So first one is radiography or radiology, fluoroscopy, mammography, and computer that means tomography. All these things that means can be said to be that means falling under the that means broad category of X-ray. And X-ray is something that means which is known to every one of us. Every one of us, or that means many of our that means near acquaintances, okay, must have that means undergone that means some kind of that means X-ray, and so we are that means quite that means we are comfortable or that means knowledgeable about that means what is the X-ray. Okay, so next one is what is called the nuclear medicine imaging. Another one is single photon emission computed tomography, positron emission tomography, magnetic resonance imaging, ultrasound imaging, Doppler ultrasound imaging, fundus imaging, optical coherence technique tomography. These are the major kind of techniques of medical imaging which are used to obtain the images of that means the most part of the human body. And what will that means explain subsequently that many of them can be prescribed for some reason for in certain situations, because in most of the cases whether the radiation or the interaction with this particular kind of that means the technique, how they will that means really that means behave with your that means the body is also that means equally important. Okay, so next, that means let us go to your electromagnetic spectrum. And I believe that means most of the participants are from classical electrical science. Either that means they are from electronics and communication, electronics and instrumentation, computer science, or electrical. And you are that means quite familiar with this particular electromagnetic that means spectrum. So here that means we are having the that means frequency as well as that of the that means wavelength. And based on that means what kind of frequency and what kind of that means wavelengths are there, what we can do that means we can use them that means to do the that means imaging of that means anything. It can start with that means nuclear medicine. It can analyze determination, infrared, MRI, and then microwaves, visible one as well as that of your that means X-rays. So how can we that means make a division of this electromagnetic that means spectrum? 1 to that means 10 kilohertz is alternating current is used only for that means electrical impedance tomography, a rather exotic medical imaging that means technique. Okay, 10 to the power 4 to 10 to the power 8 hertz. The radio frequency range is used not only for broadcasting but also in that means magnetic resonance imaging, a widespread that means imaging technology for acquiring 3D volume data of excellent that means soft tissue contrast. And in many of that means the kids and that means the younger people, where a CD is that means recommended, the parents or the alternate medical opinion is that instead of that means going for a CT, you please go for a that means MRI. 10 to the power 8 to 10 to the power 12. This is the microwave range. It's well known by connoisseurs of unhealthy food, but that doesn't play that means a major role in medical that means imaging. The microwave range is that means hardly ever used for that means medical imaging. 10 to the power 12 to 7 into 10 to the power 14 hertz. This is what is called the infrared, invisible to human eye but perceived as heat. Is used in some medical applications like near infrared imaging. 4.6 to 10 to the power 14 to 6.6 into 10 to the power 14 hertz. This is a very narrow spectrum of visible light. The one part of the electromagnetic spectrum most important to man. It is used in light microscopy and histological imaging, endoscopy, and optical coherence tomography or OCT in the medical imaging. The next one is that means 4 into 10 to the power 14 to 10 to the power that means 18 hertz. This is the UV radiation plays a role in fluorescence imaging. Even more important is the fact that from this frequency domain onward, the photons have sufficient energy to ionize molecules. It is therefore possible to damage biological tissues by removing electrons from molecules, thus changing the chemical properties of the matter. The energy per mass deployed by ionizing radiation is called a Netlista dose. 10 to the power 18 to the 10 to the power 20 hertz. X-rays are possibly the most important type of radiation for medical imaging. It is affordable, cheap, and can be carried out anywhere. Okay, the kind of equipment and other things which are required are also affordable. So in most of the cases, doctor will usually or at the first instance will prescribe an X-ray. And beyond that 10 to the power 20 hertz, radiation is usually a product of radioactive decay. Since gamma radiation may penetrate tissue easily, it is widely used for diagnostic purposes in nuclear medicine, okay, scintigraphy, single photon emission computed tomography, and positron emission tomography. These high energy photons are also used for therapeutic purposes in radiation therapy, where malignant tissue is destroyed by a focused deployment of high dose in the tumor. The treatment beam of the linear accelerator can also be used for imaging by means of the so-called electronic portal imaging devices, or that is the EPID. Okay, so here that means the beyond 10 to the power 20, we can use it for that means the yes, we can use it for imaging as well as we can use it for treating the patient also who are suffering from cancer or a similar thing. Now let us see what are the kind of classification we will usually do for medical imaging. Okay, so classification of medical images, what we can consider is that, okay, this is what is the source of energy that used for the imaging. Will determine what kind of imaging you have to, you can deploy or you can prescribe. So the three broad classes are external, internal, and second one is the combo pack. In a combo pack, it can be external as well as your internal. So the external types are X-ray radiographs, X-ray mammography, X-ray computed tomography, ultrasound imaging and tomography, optical transmission, and translumination imaging. In case of the internal one, we have nuclear medicine, the single photon emission tomography, in short, which is called the SPECT, and nuclear medicine positron emission tomography, which is also called the PET. And where a combination is really required, we usually go for magnetic resonance imaging, MRI, PMRI, as well as your fMRI. Or what we can do we can go for optical fluorescence imaging, electrical impedance imaging. So the most important part is that the image processing will require what kind of image you have captured. So what are the major modalities? The major modalities. What are the major modalities that we usually consider in medical imaging? We can go for a projection X-ray, which is called the radiography. We can go for a X-ray computed tomography, which is called the CT. Then magnetic resonance imaging, ultrasound, nuclear medicine, magnetic resonance angiography, and the fundus images. Okay. So what we find is that the first thing is that the most primitive one, or the things which was initially invented in 1895, the X-ray. Okay, so it was the Wilhelm Conrad Röntgen reported the discovery of the new base, and most likely the legend is that he was unable to give some kind of appropriate name. And so since in science and engineering, any unknown quantity is that means represented by an X. So, and that is some kind of legend has said is that this is why that means this is what in these new days which came up in as what is called the that means X-rays. Okay. And so Ranjan that means received the Nobel Prize for his that means discovery in physics in 1901. Okay. So in January 13, 1896, the first clinical use of that is X-rays by two British doctors to find a needle in a hand. A beam of X-ray is directed through a patient onto a film. The film provides a measure of the ray attenuation in the tissues. And what you can do that is you can very easily that is locate where it is. And these are the kind of that is a sample that is the X-ray slices, which you must have that is come across. Okay, one type once or that is the other type in your life. So next one is what is called the computer tomography. 1967. The computer tomography that means something that means which is again that means not by a doctor. Rather that means it is invented by a computer expert and is what is called the G. Hounsfield. And this November 8, 1895 is when the that means the X-ray was that means the first developed. So your CT is also that means the another form of that means the X-ray. This is the reason the relation with that means the X-ray and CTR that means the always connected. Okay, and so what happened is that this G. Hounsfield computer expert and A.M. that means the Cormack, the physicist, they together that means the won the Nobel Prize in Medicine in that means the 1979. What is that means the really that means the helps you to see, provide a 3D anatomical information. It preserves the topology. And the disadvantage is that excessive radiation and not good for the all soft tissues. So whenever that means the key is that means the recommended or prescribed with that means the CT scan, the alternative medical opinion is that rather that means that you go for that means the other kind of that means the technique, because generally that means we do not that means want to that means expose the kid to excessive radiation until and unless that this is an absolute necessity. Okay, and this is how that means what we can do that means the 3D reconstruction in CTE that means usually done. There are that means the two methods, either slice by slice, or second one is that means what is called here that means the spiral or that means the volume scanning. Okay, and this is what your sample CT slices will that means look like. God forbid, nobody should go for this one. But if you are that means ever that means undergoing some kind of that means a CT scan, the doctor is that means going to hand over you a report, and with that means the films which will be having that means this kind of slices. Next one is what is your that means a magnetic that means a resonance imaging or MRI. So how the image formation that means takes place. Hydrogen nuclei or protons under a strong magnetic field spin in fields with one another and allied with the field. And the relaxed protons in the ion produce a measurable radio signal. And so that means that it is unlike to that of your that means the CT or that means the X-ray. So where that means that the patient is not subjected to a tremendous that means the dose of radiation. And it was that means invented in the year that means the 1952. F. Bloch and E. Purcell. And their work is further that means extended by Ernst. Bloch and Purcell received the Nobel Prize in Physics in the year that means the 1952. And Ernst that means received the Nobel Prize in Chemistry in that means the 1991. The main modality for image guided that means the surgery. Superb ability to discriminate between subtle differences in tissue characteristics. It is very safe, but less accurate for that is the bone scattering. So what you will find is that each and every that is the medical imaging modalities or techniques are having that is the some plus points, are having that is the some that is the minus or negative points also. Okay, these are what is called your that is the sample that is the MRIs. Ultrasound, that is an image formation. How do you that means obtain the that means the image formation? An ultrasound energy is propagated into the patient from a transducer placed on the skin, and backscattered echo signal is recorded by the same that is the transducer. Okay, and it was that means invented by Samuel H. Maslach in 1979. It is non-invasive, very clean and safe. It is inexpensive because your CT scan as well as MRI scans are that means quite that means expensive. They are only that means cheap in that means government facilities. The moment that means you try, yeah, you are going there to a corporate or a private hospital for MRI or CT scan, it will be that means quite expensive. Gas filled and body structures cannot be that means imaged because they absorb that means ultrasound waves. So if you are having that means too much of that means gas, okay, then also that means you cannot that means go for ultrasound. So this is something that means which we will find that some simple ultrasound that means images, and this is what is an arrangement. So those that means who must have that means undergone that means an ultrasound that means a test must be very familiar with this one. This is the that means a monitor. There is a gel. You have a that means a computer panel. This is what is your that means a radiograph, and what the radiographer is doing is that means he is moving your transducer over the gel that is which is that is spread over your body. Next one is positron emission that means a tomography or that means a PET. The image formation, detection of radiation from the emission of that means the positrons. It was developed that means between 1998 that means 2001 by Dr. David Townsend and Dr. that means Ron Knoll. It's a variable technique in some diseases and that means disorders. Amount of radiation is that means very small. It is invasive. Inject that means radioactive material into your body, and only then that means you can take the image. Okay, so these are what is called your that means the sample that means the PET images. Okay, so another one is that means what is called that means angiography, MRA, magnetic that means resonance angiography. Image formation, imagine the blood vessels. Okay, and imaging the blood vessels moving speeds under that means the MRI scan. It can be phase contract angiography. It can be contrast enhanced angiography. It can be computer tomography angiography. It can be that means the DSA, digital subtraction angiography. It can be that means the time of that means the flight. So these are the various kind of that means the angiography which are that means carried out by that means the medical profession based on that means where the problem is there. And once that means you are having this angiography done. Okay, so these are the samples of that means the angiography which are taken from that means your DSA, which are taken from that means the CTA, which are also taken from your that means the TOF. Okay, the fundus photography is the next level of that means the imaging modality. Fundus photography, also called fundography, is the creation of a photograph of the interior surface of the eye, including the retina, optic disc, and macula. Fundus photography is that means performed by a fundus camera, which basically consists of a specialized low power microscope with an attached camera and that means a posterior port. Okay, so these are the kind of that means the sample that means the fundus images. Fundus photography is used by optometric, ophthalmologists, and trained medical professionals for monitoring progression of a disease, diagnosis of a disease. Okay. Next one is, so let us see that means what kind of the basic medical image processing that means the technique. So far we considered is most of the things we considered in the previous slides are the various mechanisms that is by which the image can be acquired. So this is something that is what we call that is the image acquisition. And once that is the image is that is the captured, what is most important is that we need to then process the image. And once the processing is done, we need to do the visualizing or recording. What is most important, that means from the point of view or perspective of that means the medical image processing by that means the scientist and engineering community, other than the healthcare professional, is that means there is the processing component. Okay, so the processing component can have that means many that means the sub-component. Rather, it will be pre-processing can be done. The pre-processing will have to be that means done. Then we can go for that means the segmentation. We can go for the detection. We can go for analyzing it. Then we can go for the diagnosis. Okay. So once that means the basic image processing system is that means understood. It has that means the three fundamental components: acquisition, processing, visualizing, or reporting. The most components are there in the processing, and this is the area of our interest, because most of the medical image capturing is done by the trained doctors who are called the radiologists. Okay, pre-processing, segmentation, detection, analysis, and diagnosis. This is where all our accumulated knowledges can be applied to arrive at some kind of conclusion, which will be quite correct. Okay, so your acquisition of images that is as we have that is already considered is that it could be X-ray, it could be MRI, it could be CT, it could be MRA, it could be PET, it could be mammogram, it could be that is ultrasound, and that is many more. Okay, so once that is your imaging is done, then what happened is that in the pre-processing of the images, what we have to do is that the most important thing we have to do is that we have to filter the signal first. Okay, once the filtering is done, then the blooding and that is the other effects which are present for one reason or the other reason are required to be removed. And so this will be nothing but some kind of noise. What you can say is that this is the next stage is what is your image noising. The third one is once the image denoising is done, we need to now look into what is called the image registration. Okay, so once the filtering is done, image denoising is carried out. We need to go for the image registration. Once the image registration is made, then we have to go for the image enhancement. Okay, so all these steps are quite challenging. Okay, and every subsequent step will depend on what kind of technique you have used in the previous step. Okay, so list of algorithms for pre-processing. You must be many of you are already working in this particular area, and those who are having some interest of the medical image processing may find the list of pre-processing techniques which are commonly used. Either we use a median filter, or we take the help of a wind filter. It can be wavelet based denoising. It can be wavelet based image registration. Okay, so once this pre-processing is done, they exactly delimitate objects once they are detected. Okay, whether it is a vessel, whether it is a liver, whether it is a cardiac imaging, left ventricle, or whether it is a brain, it can be very easily identified. Okay, so the various kind of segmentation algorithm which are used in medical imaging is K-means, fuzzy, neuropuzzy, neural network based segmentation, snake algorithm, thresholding based segmentation. But one thing is that every the algorithm that you are going to deploy will depend on what kind of imaging modality was adopted, and what is the quality of the image that you are working, what kind of pre-processing you have undertaken. Okay, so once this is done, now comes the question of what is called the detection. Find location of objects of interest without the prior knowledge about their location as well as existence. So whether it is a bone, organs, polyps in colon, and nodules in the lungs. So after that image processing is done, Okay, what you can do that is we can detect whether it is a bone, it is an organ, polyps in colon, or nodules in lungs. Okay, so then what you have to do that means we have to go for that means analysis. Once the detection is done, it can be that means a measurement, volume probe, or a vessel stenosis. It can be that means the functional imaging, stroke, cardiac perfusion, as well as that means the demand perfusion. Analyzing that means you will be then able to say whether the person suffered a stroke or that means it was a cardiac perfusion or whether that means yeah, it is a tumor perfusion. Or what you can do is that from a that means cardiac function, left ventricular motion as well as that of the that means ejection fraction. So all these things can be that means worked out once the analysis of the medical imaging is carried out. Okay. Now, the question next comes, what kind of that is the classification or the diagnosis that you can make after doing your image classification, your analysis. What you have to do is that you can compare your result with developed that is the atlases. Atlases are nothing but some kind of a that is the database, which are that is the already established or created. Okay. Use of that is the knowledge databases. So generally, for medical that is the research or image researches, there are a lot of that is the databases that is the available. So you can compare that is the how your result is that is the very or that is the confirming with whatever is that is already there with the known that is the databases. The most important thing is that the image processing will give you an understanding whether the brain is normal or that is the abnormal. And another thing is the most important thing is that whether it is benign or that is the malignant. Benign means it is harmless, malignant means it is problematic. And finally, that means what you can do that means sometimes you will be that means able to find out whether it is that means cancerous or it is that means non-cancerous. Whether it is carcinogenic or that means non-carcinogenic. Because the medical fraternity usually use the term that means carcinogenic or carcinoma. But common people say it to be the cancer or your that means a non-cancer. Okay. So the list of applications can be what we can do that means after medical image processing is that we can go for medical image compression, medical image denoising, image filtering, medical image that means a retrieval, mammograms, tumor detection, as well as that means a medical image fusion. Okay, so next that means I now move over to what is called the computer-aided diagnosis of medical images using that means the deep learning. Now look into this is what is called that means the process flow diagram. So what is most important here is that you have to that means find out that means the feature learning, feature transferring, as well as your that means the classifier that means the learning. You are having the that means the image that is the training image that means the set. And you are having that is a training image that is the data. And then what you do, you go for that is a convolution layer, fully connected that is the layer. And then what you really do is that you go for that is the tuning the various parameters. And so from your that is the training image data, you get that is the multi-layer that is the features learning. And from the image net, what you get the output of the convolution layer, you get that is a fully connected layer. You come across an output layer, and finally that is what you can do. That is you can go for that is the classification. Okay, so classification of that is medical images using that is the deep learning. This is a very good that is a paper, and this is taken from Antari et al.'s one, a fully integrated computer-aided diagnosis system for digital X-ray mammograms via the deep learning detection, segmentation, as well as your classification. Okay, so and it was published in International Journal of Medical Informatics. Okay, so here you have the input data, and you have a deep feature map. And finally, what happened? You have the classification output. Okay, and all the color coded one is giving you some idea regarding the convolutional layer plus RLU. Okay, then your normalization layer, and finally what you get is that your max pooling layer. Okay, the question is that what is the deep learning? A machine learning subfield of learning representation of data exceptionally effective at that means the learning patterns. Deep learning algorithms attempt to learn multiple levels of representation by using a hierarchy of multiple layers. If you provide the system with tons of information, it begins to understand it and respond it that is the useful. And what happens is that these two that is the picture will that is the tell you. Okay, the fundamental difference between that is the machine learning, which is that is the mode of a that is the generic nature, and in case of that is the deep learning, which is therefore that is for a specific one. Okay, and so all these foundations are comes from that piece of your brain inspired that piece of learning. So what happens is that just the way that piece of we do, we learn from a that piece of massive that piece of data around us, and then we have to find out what are the that piece of simple functions, and finally that piece of we have to represent the same that piece in a multi-layered one. Okay, this is something regarding the further that piece of representation of your that piece of convolutional your networks. Okay, convolutional that is a neural networks. I believe that with those who are working on this one is that convolution and pooling, and fully connected, and what happens is that you get your that means the output prediction. Okay, architecture of your that is a convolutional that is a neural network. Okay, you have the image, input image convolution, then you do the pooling, then you again redo the convolution, again pooling, and finally that means so you are having the hidden layers as well as that of your that means classification layers. Okay, so this is that means one more one. So regarding your that means a convolutional neural network. Okay, so the other pre-trained that means the convolutional neural network is that AlexNet is there, GoogleNet there, BGG, Inception, ResNet, and SqueezeNet. So these are the already that is a pre-trained convolutional network. And what really happens is that after automatic that is a feature extraction using that is the deep learning. So you have a that is a low level feature. What happened is that you upgrade it to that is a high level feature. Then you find out the high level that is the feature, and finally that is what happened that is you can find that is a trainable classifier. So this is what is called the representation of your that is the deep learning that is the processes. So your low level features are there, mid level features are there, and finally that is what happened is that you have that is the high level feature from your this is together that is what is your that is the deep learning model. Now, some of the works techniques which are done by students as well as that means our group that means in the institution. One is that means the 2D that means the brain tumor detection using memory-based that means the learning method. So here that means what happened is that so he did learn a threshold value in the training phase by comparing that means the fuzzy Siemens clustering tumor area with original MR image intensity value. Supervised learning algorithm was used, shifting the iteration process from testing phase to training phase for faster identification of tumor region in detection phase without that means affecting the accuracy. And this work was that means published in that means the multimedia tools and applications in the year that means 2019. And the outcome is the unseen that means the input slice image, special histogram stretched image obtained for contrast enhancement. And finally, what happened is that we are able to detect the tumor portion. Okay, so next one is a 3D that means the brain tumor detection. It's a combination of that means the two phases, namely contrast enhanced fuzzy Siemens clustering and pixel based voxel mapping technique. And contrast enhanced fuzzy Siemens clustering means fuzzy Siemens clustering segmentation after contrast enhancement. In pixel based voxel mapping technique, each segment pixel of all 2D MR slices are mapped into the 3D space. Enhances accuracy since effort has been given to improve precision in both the phases. Okay, this work was also that is published in Journal of Ambient Intelligence and Humanized Computing in the year that is 21. Okay, the third one work which he that is carried out is that 3D brain tumor detection with confidence function that is evaluation. Similar to the other methods, except the confidence function that is evaluation. Confidence function has been evaluated to reduce the positively detected false abnormal area from each 2D segment output. Many pixels are not considered as tumorous area if their confidence function value falls below the threshold level in order to reduce the error. And confidence function has been evaluated based upon 3 parameters, namely self-pixel intensity, neighboring pixel intensity, and probable tumor area calculation using Otsu algorithm. This work was also accepted for publication in multimedia tools and your application. Okay. Another work that Mr. he carried out is that histogram peak analysis, a fast skull stripping technique for that Mr. brain images. Okay, the skull stripping algorithm has been improved by using only one threshold operation. Elimination of one thresholding operation further reduces the computational that Mr. time. And this work was that is accepted in IEEE, that is the International Conference on Advanced Communication Technologies and Signal Processing, ACTS, that is the 2020. Last work done by my scholar is simple and fast skull stripping that is the technique, which was also that is the accepted in a conference and which was subsequently that is published by a journal. Stripping skull portion is required to avoid false detection during segmentation. Uses 2 number of thresholding operation, eliminates morphological opening and closing operations to speed up the algorithm. So these 5 that means the works are that means carried out by that means my student who defended his thesis that means only the last month. Okay. So this is a work that means carried out by my colleagues in the department from the that means medical image processing group. Okay. What they have done is that they have that means they have done a work on diagnosis of retinal images that means using that means CNN. And if someone that means wishes to that means collaborate, they may contact him, Dr. Murugan, and this work is also that is published in that is multimedia tools and applications. Okay, this is the second work that is done by our that is group, which is diagnosis of that is COVID-19 through X-ray images using that is deep convolutional network. Okay, this work was also that is published in Journal of Ambient Intelligence and Humanized Computing. And the authors are, both the authors are that is assistant professors in our department. One is Dr. Murugan, another one is that is Dr. Timsiguel. They are very good at that is medical imaging. If anyone that is wanted to connect with them, that is I will help you that is to connect with them. Okay, so this is the third work that is done by our that is group, diagnosis of COVID-19 through X-ray images using that is optimized CNN. Whenever a COVID patient is that is admitted, lot of that is X-rays are that is taken to ascertain the condition of that is lung. So what they did, that is say they that is used optimized CNN to find out that is what is the nature of the ailment or the damages. So this one is a paper that is by Dr. Timsiguel, Murugan, and they are all that is teachers. So which is also that is published in that is applied intelligence. Okay, so this is another that piece of work from our that piece of group, diagnosis of COVID-19 through CT images using that piece of optimized generative that piece of adversarial network. This is also published in that piece of cognitive computation. Okay, now what are the common challenges in medical that is the data analysis using that is the deep learning? What is very that is important? In the right hand side, what you find is that we have data, and then what we do that is that we build up a model, and finally that is that we try to that means work out a result or make some kind of your conclusion. Okay, so the most data collection, how many images that is that we need? That is one of the that is the most important thing. If the images are that is the too less, then perhaps our data repertoire will be that is the very that is the limited. What if we do not have enough data? And what if we do not have enough annotations? So these are the things which are required to be kept in mind while considering medical data or medical image analysis using deep learning. And can you use deep learning to obtain or achieve a reasonable result with a very limited set of data? Next one is very important. What model selection? Do we really need deep models? You need to consider, and you need to give it some thought. Do I really need to go for a deep model? Now we have a tendency nowadays is that there are too many tools which are available before us, and whatever is the kind of input we are having, we can fit this input to any such tool, and definitely we will get some kind of output. Is this always good, or is this always acceptable? This is also something as a researcher you need to consider. Do we really need deep models? Okay. Does the model require deep learning? Second one is there any off-the-shelf model? Should you build a model, or should you borrow a model which someone has already worked on? This is something which you need to also work out, because building a model is also time consuming. Okay, and there is no guarantee that the model that you will build will be giving the desired output. How can we incorporate context or prior into the models? This is also equally important. And is there more trainer-friendly models? Because all such model will require training for their learning purpose. So can we have a user-friendly model? And while you go for result interpretation, can we visually interpret the result? Is it possible just by looking into the result? Then I will be able to say this is what or this is what not. Or can we obtain human-friendly interpretation? So these are the things which are common challenges in medical data analysis. There cannot be exactly an answer for any of them. As a researcher, you need to find out what is good for. Okay, so this is something which is called novel training methods in your deep learning. Okay, transfer learning as well as your extreme learning. And third one is what is called your optimized learning. Okay, so whether you can transfer it from the scratch. Okay, and so here what happens, and similarly you can do the extreme learning. And finally, you can also look into what is called optimized learning. So you may consider of using any of this learning method in the training stage, and this will give you what good your result will be. Okay, so key research problems in medical imaging is diagnosis of COVID-19 images. So COVID is there, and most likely that is not going away. That is very soon. As we can observe from various kind of reports from the medical bosses of the country as well as from the world health organization. The COVID is something which is not going away. That is shortly. So we have a tremendous great challenge which is there in our mind. How do we analyze and process the COVID-19 images? Why figure the active COVID duty healthcare professional, because he is a doctor and she is an anesthetist. That way the people from medicine and anesthesia are someone who are managing the COVID-19 situation. Okay, so in most of the cases, what we find is that the large images of many of these COVID patients are damaged beyond any kind of repairable extent. So can we make out something, or can you use medical imaging to analyze those COVID-19 images? Lung segmentation of COVID-19 images, retinal images, detection, classification, as well as segmentation. A large number of our people are suffering from vision-related problem. Okay, so can we prescribe or that means detect that means a better kind of that means a method, so that it is fast, it is accurate, and that means it involves less amount of cost. MRI images, cancer detection, as well as that means so in retinal images, MRI images, and cancer, we need detection, classification, and segmentation in all the that means the three cases. Similarly, is it possible for automatic translation of medical images to text or that means the image? Okay. Okay, so this is what, right? So let me now move to conclusion side. Okay. So what we can conclude is that deep learning, that means the based medical image analysis, has shown that means the promising results for data-driven medicine. By adopting recent progress in data learning, many challenges in data-driven medical image analysis have been overcome. Deep learning has the potential to improve the accuracy and sensitivity of image analysis tools and will accelerate innovation and new product launches. Okay. So what you can do, that means these are the key research, that means the findings, that means which are there. Okay. Computer aided, that means the detection, computer aided detection today failed to that means the meet expectations, but the market is that means the forecast to see renewed that means the growth. Okay. Only quantitative imaging tools, radiology will evolve from a largely descriptive field to a more that is the quantitative discipline. So far, what that is the most of the that is the radiologists do, that is the they offer that is the descriptive or a qualitative kind of a thing. But what is very important is that you need to have that is the quantitative, that is the interpretation. Until and unless the quantitative interpretation is there, it will not be that is the full, will not be that means the fully able to that means appreciate the same. Decision support, that means the tools that combine that means the quantitative imaging and that means the clinical workflow features will improve diagnostic accuracy, radiology reporting, and enhance that means the radiologist productivity. And computer aided, that means the diagnosis. Because the moment the radiologist that means the look into a that means the plate, sometimes he needs that means a lot of time to make a that means the conclusion that means what it is. But if we can that means the process it at a faster rate, because now we are having that means the very that means the high resolution, fast that means the computing systems are as available. So what we will get that means the productivity of the radiologist also improve. And computer aided that means the diagnosis, cognitive physician support tools that provide probability driven differential diagnosis as poised for growth. Okay, if Federal Drug Administration USA is permitting, then possibly that means the computer aided diagnosis will be that means a very soon will be that means a legal kind of thing. And these are what is the future directions in that means the medical imaging data. Further studies to incorporate clinical knowledge into data-driven that means the model. More studies on the application of recent advances in unsupervised or reinforcement learning to medical image analysis. Studies on higher dimension, 3D, 4D, or even higher medical image analysis. However, the greatest market impact in the short term will be from cognitive workflow solutions that enhance radiologist productivity. Diagnostic decision support solutions are close to commercialization, but several market barriers need to be overcome. Example, regulatory clearance, legal implications, and resistance from the clinicians. AI will augment, not replace physicians. Radiologists become physicians of physicians. So the future is that means on radiologists. Okay. So this is a good book on that means the fundamentals of that means the medical imaging by Paul Swetten. Okay, those that means who are interested for that means the medical imaging and medical imaging analysis. Okay, I recommend them that means to procure this book and that means the study it. Hopefully that means this is going to that means enhance their knowledge of that means the understanding of that means the medical imaging. Okay, and for deep learning, my suggestion is that Mr. Ian Goodfellow, Yeshua Benizio, and that Mr. Aaron Kogel. This is also that Mr. very good that Mr. textbook on that Mr. deep learning. But simply that Mr. if you study both this book, one on that Mr. medical imaging, then and second one on that Mr. deep learning. hopefully that means you will understand and appreciate each and every component of that means medical imaging processing involving that means deep learning. Okay, so thank you all. And that means if you wish to that means connect with me, this is my that means mail ID. I will help you to connect with my that means group in the department, and together that means what we can do that means we can that means expand the scope of that means biomedical image processing research in our country, and in turn that means which is going to benefit the entire that means humanity. So thank you all. Over to Dr. Da.
Thank you, sir. If any participant would like to ask any questions, please write in chat box. I think no questions. Once again, thank you, sir. It was a very effective and informative session, and you have covered medical imaging, classification of medical images, modality, classification, application, and CAD. All these topics were very interesting. It will help the participant in their research, sir. Thank you very much for connecting with us, sir. Thank you, sir.
Okay, thank you. Yeah, thank you, Dr. Kumar. That means I will share the PPT that means with you. If any of the that means participant is interested, they may that means share. Okay, they may take a copy. That means a problem.
Okay, sir.
Okay, okay. So thank you all. That means thank you.
Thank you, sir. Dear participant, now we have a lunch break and we will meet again at 2:30 p.m. Thank you all.